Okay, so another way this question could have been said, you might see it on the AP exam as simply estimate the square root of 9.13. Same thing. So let's get started. Where is it? Okay, so anyway, our first step, write down step 1, is to write the equation of the tangent line at x equals whatever is the nice number that was given. In this case, what's my nice number?
9.
9.
9. X equals 9. So we know to write the equation of a tangent line, what two things do we always need if I want to write the equation of a line?
Point and slope.
A point and a slope. So let's first find the point, which is going to be 9 comma f of 9. Plugging in 9 into the square root, it simply is obviously 9 comma
3.
3. Okay, that's our point. Straightforward. Just plug it in. Square root of 9 is 3. Next, we need to find our slope. What's another word for slope in calculus?
Derivative.
There we go. I need the derivative. So we're going to write f prime of x. What's the derivative of square root x? Guys, this should be
1 over 2 square root x. 1 over 2.
Over 2 root x. But we don't want the slope at any point. We want the slope at x equals, careful, at x equals 3 or 9?
9.
9.
At 9. Okay, don't mistake. At x equals 9. So plugging it in, I get 1 over 2 times 3, which is
1 over 6.
1 over 6. That's my slope. So once I have my point and my slope, I can finish step 1. Let's write the equation of the tangent line. So it's y minus
y1,
which is 3 equals m, the slope,
1, 6.
1 over 6.
parentheses x minus
9.
9.
9. Cool. So that's step 1 done. We wrote the equation of the line.
Wait, why x minus 9 again?
That's the formula. Y minus y1 equals m, x minus x1. This is my x, that's my y. So what did we just do? We wrote the equation of this blue line. Now we're going to plug in our numbers. So write down step 2. So step 2, we're going to isolate y. Then we're going to replace y with f of x. And the equal sign, we'll replace it with the approximation symbol. Please write those things down. So step 2, we'll isolate y. We'll get it by itself. Then we'll replace y with f of x and the equal sign with an approximation. How do I know? Because it says estimate. You're estimating. So we can't say equals. You will lose a point on the AP exam. So let's get y by itself. What should I do to both sides?
Add 3.
So y equals 1/6 parentheses x minus 9 plus 3, just like that. Okay, now I want to replace y with f of x and the equal sign with an approximation symbol. Here, nothing clever is happening. We're just saying it's an approximate value. Now we have our tangent line approximation. Now we simply need to plug in 9.13. So step 3 is plug in x equals, and this will be our weird value. So let's do it. So I'm writing f of 9.13. That's what I want to approximate. Now, everywhere I see an x, we're plugging in 9.13. Tell me what to write.
1, 6.
Over 6.
1, 6,
Parentheses.
parentheses, 9.13 minus 9, parentheses, plus 3.
Very good. And we can do this part. So 9.13 minus 9, it's 0.13. I need you to convert it to a fraction. So 0.13 is 13 out of what?
100.
100.
Very good. So that's 13 out of 100. I went over this in the lecture video. If there's 2 decimals, it's over 100. Plus 3. Now in our last step, let's multiply across. So 1 times 3 is 13. 6 times 100 is 600. Add 3. What can I do in the last step?
Fraction trick?
Fraction trick. 600 times 3.
9, no,
1800.
1800.
Plus 13
1800.
1813.
and 13 divided by
600.
600.
600.
Somebody plug that into a calculator. Guys, this is our final answer. F of 9.13 is approximately that. Somebody plug that into a calculator. Tell me what our approximation was. Let's just see how close we are. And then somebody else plug in square root of 9.13 to see what the actual answer is. Let's see how close we are. So what's 1813 over 600?
0.305.
I got 3.0216.
Oh,
Yeah.
oops, I see what I did wrong.
Okay, 13.02166 repeating basically. Now, what was the actual value of the square root of 9.13? Somebody do that.
3.021588 9 and so on.
3.02158? Another 8?
Oh,
Yeah.
Holy hell, you guys! Using calculus, okay, using the tangent line approximation, we got this accurate to 1, 2, 3, 4. If you round that up, we would be accurate to 4 decimal places.
let's
That's
go.
how close we are. That is such a trip. So that's the tangent line approximation. Number 2 will be on your homework. Okay, come to office hours if you want to see it done. And then 24 here is actually a released AP question. So we will do that also in office hours. It's also on your homework. Come at 3:50 if you can, if you care.
Wait, Miss, quick question.
Too.
When
Yeah.
you're writing down the answer, do you want the fraction or do you want the decimal given already?
Oh, no. You can't do the decimal, right? Because we don't know. That's
Oh, okay, okay.
This is no calculator. The question is approximate it. This is our approximation.
Okay.
So really important, when you get the decimal in here, convert it to a fraction so that you can use the fraction trick for a final answer. All right, cool guys. Let's go to part 2. We will review the chain rule, starting with a review of the chain rule. So copy down A. E to the power of f of x. Now recall, the chain rule says it's called the outside-inside rule. So first we'll take the derivative of the main function, the outside function, holding the inside the same, fixed. Then we multiply by the derivative of the inside function. I'm going to call the inside function monkey because it could be anything at all. Anything at all. It could be 2x plus 1, cosine. It could be whatever. So let's look at A. Isn't this e to the power of monkey? Yes, because it's not just x.
Yeah.
Yeah.
What's the derivative of e to the monkey?
E monkey.
E to the monkey.
E to the monkey times the derivative of monkey comes afterwards. And the derivative of f is f prime. Let's do B. Ooh, this time what's my outside function that I'll take the derivative of first?
F.
F is the outside function. It's f of something. So f of monkey, what's the derivative?
F of monkey.
F prime. Careful, I want to take the derivative of the outside. And the inside guy stays fixed. Last step. Multiply by
Derivative.
derivative of e to the x, which is just e to the x.
What do you need to do one more there or no?
What?
Oh, never mind.
Okay. Let's do C. Kaylee Franco, can you guide me with C? So for this one, I'm going to do it above because I don't have much room. So how will I take the derivative of f of 1 over x? Quick.
1
Derivative
over
of the
x squared.
outside. Careful. The derivative of the outside function first.
Yes. F prime 1 over x.
Good. That stays fixed
1 over x squared.
times the negative 1 over x squared.
Negative 1 over x squared.
Put it in the negative. Okay, that's the derivative of that. So we're taking the derivative of the outside, the inside guy staying the same, then we multiply by the derivative of the inside. Okay, Bridget, let's do D. Ready? Outside guy first, take its derivative, go.
So the cosine. And then
Of,
f of x.
good.
Then we multiply it times f of x, would it be?
What's the derivative of f of x?
F prime, I think it is.
Yes, that's how we say the derivative of a function. The derivative of g is g prime. The derivative of h is h prime. Okay, Michael, tell me why E is different from D.
The sign is in the parentheses.
So let's take the derivative of the outside guy first. Go ahead, Michael.
So it'll be a f prime, then sine x stays the same in the inside. Then multiply that with a cosine x.
Very good. The derivative of the inside at the last step. Okay, Naya, tell me how to do the derivative of natural log monkey. What's the derivative of natural log from your formula sheet?
Sorry, can you repeat that? You're cutting off a little bit, but I heard my name.
The derivative of natural log monkey, what is it?
Of the natural log, isn't it? No, that's not. It's not e, right?
Somebody help. What's the derivative of natural log? Always.
1 over
Memorize.
x.
1
1
over
over
x.
1 over. So if it's the derivative of natural log monkey, it can be 1 over
F of x
what's inside. Keep going there.
times the derivative of. Oh, it stays the same. F of the derivative of f of x, which is f prime of x, right?
There you go. So we have 1 over monkey times the derivative of monkey. 1 over f times f prime. Let's do g. Anne-Marie, help me with g. So take the derivative of the outside first, keeping the inside the same. Go ahead. Guys, you try it as well. Don't wait for her.
Okay, it will be f prime
Of?
of square root x
Very good. Keep the inside the same. Times, let's finish.
times 1 over 2 square root x.
Nicely done. Very good. Okay, guys, do H yourself. Mr. McDowell, go ahead.
So it'd be 1 over 2 square root f of x times f prime of x.
Beautiful. This time the outside function was square root. The derivative of square root monkey is 1 over 2 root monkey times the derivative of the inside. Last one, tangent of f of x. Write it down. Try it yourself. Take the derivative of the outside first, inside stays fixed. Rochelle, what's the derivative of the outside function?
Square x, f of x stays the same times f prime x.
Ta-da! Just like that. Very good. Secant squared f of x times f prime of x. Ashley, did you get that? Ramon? Haley? Reyes, did you guys get that? Okay, great. Let's move on. Any questions? Yes.
Can you go over f one more time?
F. Okay. So the derivative of natural log x, you should have this memorized, is 1 over x. So the derivative of natural log of a function will be 1 over the function followed by the chain rule, since it's not just x.
Got it.
So for instance, the natural log of x squared would be 1 over x squared times 2x. Did you see how I multiplied by its derivative?
Yeah, makes sense.
Okay, cool. Let's move on to the next part.
Where'd you get 2x from?
The derivative of the inside.
Oh.
Times the derivative of the inside. We always times by the inside. All right. So let's go now to the next part. Write them down. Go ahead and write these down. Cosine y, square root y. Okay, we're going to do the same thing as above, except instead of f of x, I'm going to use y now. I'm replacing f of x with y. And you might be wondering, why now? Because that's what we're doing. That's the point of the lesson. We're using y now. All right, so let's begin. So here's the deal. Y is a function of x. So we're still taking the derivative, we say, with respect to x. Right? How fast is y changing based on how x is changing? So y is a function. Please note, y is a function. So we still use the chain rule. So the derivative of cosine y will be derivative of the outside first, which is what?
Sine.
Negative. Be careful, man.
Sine.
Negative sign. Inside guy stays the same. Times the derivative of the inside guy. And the derivative of y is y prime. Write that down.
Can't you substitute y for f of x?
Well, you're not going to see f of x. That's the thing. On problems like this, it will say y, and I want you to be used to using y. Okay? And you'll see in a second why. So just trust me. Just trust me right now. So we're using the chain rule with y. Okay, let's do the next one. Square root of y. Guys, what's the square root of y, the derivative?
1 over 2 square root y.
And since y is a function, we'll multiply by its slope times y prime. Everybody okay there?
Yes.
Okay, let's try another one. Krista, what's the derivative of 1 over y?
Give me just
Do
a
you remember? 1 over x? Anybody?
Negative 1 over
Negative 1 over x squared.
Okay, so we're going to write negative 1 over
y
Y
squared
squared.
y squared. But y is a function, so followed by the chain rule, what are we writing?
times 2y.
2y.
No.
Y prime?
So,
Y prime.
yeah, just the derivative of the inside guy, which is y prime.
Oh.
sorry, miss. I had to answer a question from my mom.
Michael, you were thinking of the next problem.
Okay.
Okay, so ready, guys? Look at the next one. This one's very tricky.
Mhm.
So I observe, listen to my words. I observe a power. Write this down. I observe a power. What's my power here?
2.
2.
2. So if you observe a power, you will use the power rule. But we're going to follow by the chain rule. As we have a function being raised to power of 2. So watch very carefully. We're going to use the power rule. So if I have a 1 in front, what's the derivative of 1y to the 2? Multiply.
2y.
It'll be 2y to the 1 followed by the chain rule. By the way, that's not y prime. That's just y to the power of 1, which is just y. Followed by the chain rule, so times y prime, the derivative of the inside.
Does this only work for y?
It's only if I say, give me the derivative of y.
It's
Okay,
y prime.
let's do the next one. What do you observe here, you guys? What do you observe?
Power 3.
So we're going to use the power rule followed by the
Chain rule.
Chain rule.
no, go ahead. Let's do the number in front, which is
12
continue
y
Y
squared.
squared.
times
Y
Y
the
prime.
derivative of y prime. Ta-da. I hope it's making more sense. Try the next one yourself.
Miss Name?
On May.
Yeah. Okay. So why are we doing the chain rule? Just because it's y, or is there?
It's because y is a function of x. Y is a function. Isn't y
Oh.
usually like y equals 2x plus 3? So it's a function. Instead of
Yeah.
using f of x, I'm just using y. So it's the same
Got it.
rule.
Okay. Got it. Makes sense.
Okay, Ramon Calvillo, give me the derivative of negative 5y to the 4th.
Negative 20y cubed times y prime.
Nicely done. Very good. Okay, let's move on to the next one. So guys, when I say take the derivative, we're always taking the derivative with respect to x. So watch this. The derivative of 2x is just 2, just like our old rules. If you say, okay, if you want to explore this idea further, technically we can multiply by the derivative of x, but the derivative of x is just 1, isn't it? Isn't the derivative of x 1? So that's why we just ignore that. But now I have a function. So what's the derivative of negative 3y?
Negative 3
Times
y prime.
Ta-da! There you go. So since there was a minus sign here, we take the derivative of each part separately. We know the derivative of 2x is 2. And here we used, well, the slope is negative 3 followed by the chain rule. Okay, let's try the next one. Okay, maybe we'll try one more. Try this, negative 6x squared minus 2y squared. Go ahead and try it right now. Take the derivative of that.
Miss, do we take the derivative of both
Yeah.
of them?
Yes, because there's minus signs, you take the derivative each separately, yeah? Just like we usually do. You may give the derivative of this expression.
Negative 12x minus 4y times y prime.
Very good. Guys, make sure you understood that. Everybody okay?
No.
Said that. Krista?
Uh-huh.
Don't we know the derivative of negative 6x squared. It's negative 12x, power rule. Here, we have a function. I told you, y is a function. So we're going to use the power rule, which brings us 4y, followed by the what, Krista? Followed by the
Chain rule.
chain rule, because y is a function of x. X is not a function of x. X just is itself. Therefore, we don't have to follow it with the chain rule. So we're taking the derivative with respect to x. So
Where did
hopefully
the
this
4 from the
pattern
y
is
come
starting
from?
to begin. What?
Where did the 4 from the y come from?
The 4
Yeah.
from 2y squared. What's the derivative of y squared? 4y to the power of 1 times y prime. Check this out. What's the derivative of that? I see a power, so I'll use the power rule. 10y to the power of 1, followed by the chain rule. Again, I see a power, so power rule, 15y squared, followed by the chain rule, derivative of y. Is that better? Okay, if you have more questions on that, I'll go over it in office hours. Which insanely bright person can tell me how to do the derivative of this expression? I haven't taught you yet. Who can figure it out?
Oh, you just multiply them together now?
So what
It's
do
like
I
a
use?
mixture of
12x
product
squared times 2y times y prime. So like
No.
24x? No.
I got
No.
12x times
Tell me what I
y.
should do.
Oh,
What rule should I use?
use product, right?
Oh,
You start with
product rule.
first.
Product rule. It's the product rule. This is my first function. And this is a separate function. They're both functions, 4x cubed and y squared. So make a note to yourself. We're going to use the product rule. Circle each separately. Okay, so the product rule, let's apply it carefully. Look down, you'll be faster. Copy the first expression. And what's the derivative of y squared?
Y.
2y
Y
Times y prime.
times
y
Y.
prime. Don't forget, chain rule. Power rule followed by the chain rule because it's a y. We're not done with the product rule. Next, put plus. This time I copy the second guy. And what's the derivative of 4x cubed?
12x squared.
12x squared.
Nice, we're done. What's your friend?
Rewrite.
Rewrite it, nice and neat. So we really have 4 times 2, so that's 8x cubed times y prime, plus, bring the number to the front, 12x squared y squared. That was a product rule. We'll practice more in a second. Let's go to the next problem. Since you guys, give me a thumbs up, a thumb sideways, or a thumbs down. How are you doing on what we've done so far? Thumbs up, you're following. Thumbs sideways, you still have some questions about what we just did. Since the class seems like mostly fine, I'm gonna make this next one a little harder. Write down x squared over y cubed. Let's take the derivative of that. Okay, rápido. What rule should we use this time?
Quotient rule.
Quotient rule, very good. Let's apply the quotient rule. So the song is low D high minus high D low. Let's start there. What's my low?
Y cubed.
The derivative of the top?
2x.
2x.
Minus, now my high.
X
And
squared.
what's the derivative of the bottom?
3y squared.
You guys are forgetting something. You guys are forgetting something.
All over y.
Y prime.
Followed by the chain rule, you guys. 3y squared times y prime. Don't forget the y prime. That's the most common mistake. All over low squared. So what are we writing?
2y squared squared.
Y cubed
Y
squared.
cubed squared.
Y cubed squared, yeah? So dy to the second on the bottom. Okay, let's move on. We'll do one more. Cross out the last one. Let's do cosine xy. What rules should we use here first from all the rules that you're familiar with?
Chain rule?
Chain.
Chain rule. What's
It's the chain rule thing.
What's the derivative of the outside guy first? What are we writing?
Negative 9.
Inside guy stays fixed. Multiply now by the derivative of the inside expression. Ooh, what do I have to use to take the derivative of xy?
Product rule.
Product.
Very good. Product rule. Guys, try it yourself. So it's the chain rule. It's the outside times the derivative of the inside. Now careful, use brackets. Okay, good tip. Use brackets because you're going to multiply by more than one term. Actually try the problem, okay? Copy the first, take the derivative of the second carefully, plus copy the second, take the derivative of the first. Close brackets to finish. Okay, what did we get? Copy the first, the derivative of the second is y prime, plus
Y,
Y.
that's it.
Y
Times x prime.
derivative of
prime.
x.
X
One.
prime.
1.
No, x prime is just 1. The derivative of x is just 1. It's a slope. So there we go. There we go. So next step, if this was on a homework, you would distribute. That's why it's important to put the brackets. Okay, cool. So common mistake here. Let me show you what the common errors are. Go back to y squared. Go back here. Common mistake here is to just write 2 to the front and then take the derivative of the inside. 2 and then y prime. That's wrong because the inside guy needs to stay fixed. Another mistake is people bring the 2 to the front, y, take it to the power of 1, and forget the chain rule. That's also wrong. Please write these down. These are both incorrect. And then on the problem that we just did, x squared over, or cosine, when people use the product rule for x, y, this is the number one mistake. They take the derivative of both. They do, oh, the derivative of x is 1, the derivative of y is y prime. That's wrong. There's no product rule there. You need the plus sign and you need to take terms. So cross that out as well. That's not how you take the derivative of x, y. Also, last step, put a skull on the brackets. Very important to use the brackets when you're using the chain rule.
Why is skull?
Skull because danger, watch out. Kids die here. I found skulls.
Miss, I'm so confused.
Wait,
Why
we're
do you have
supposed to
y?
use brackets or we're not supposed to use it?
On May, what?
Wait, what? Why do you have y prime plus y? Why do you have that? That's my question.
I did, silly, I did the copy the first, then the derivative of the second. That gave me x, y prime. Plus, now I copied the second, y, and the derivative of the first, x, is just 1. So I didn't write times 1. I just wrote x, y prime plus y.
Got it.
Was there another question? Somebody had a question. Quick. What was it?
Never mind.
Okay. Now let's do a problem. See it now. So this topic is called implicit differentiation. Don't worry, we will do more practice. Okay, we're practicing now. So up until now, every time I asked you to find the derivative, y has been explicitly solved for x. For example, y equals 2x plus 3, or f of x equals cosine x minus 2x, right? So your y was already all by itself, and you knew what it equaled. But look at this problem now. You see how your x's and y's are all mixed up? So now we're going to do implicit differentiation, not explicit differentiation. Implicit differentiation is literally what we've just been doing, okay? All that's implicit. So it says find y prime. So let's take the derivative of everything. I'm going to show you the steps. Okay, so step 1 for implicit differentiation. Take the derivative. Actually, let's write it like this. Take d dx of both sides. That just means the derivative with respect to x. So starting on the left side, what's the derivative of 2x squared?
4x.
4x. Next, what do you see happening in this term?
Product.
Product
rule.
rule. Let's circle, include the negative with the 3x. Include the sign there. And the second thing will be y squared, okay? Let's use the product rule. Copy the first. What's the derivative of the second, y squared?
Y squared times y prime.
No, start again.
2y times y prime.
There you go. I need the power rule followed by the chain rule. 2y to the power of 1, or just 2y, followed by the chain rule. We're not done. Ashley Ramirez, continue the product rule for me. What do I write next? I'm still in the middle term.
So it turns into plus, and then it's right d left. So we write down the right side of it as it is.
Which is
Y squared
times
the derivative of negative 3x.
So
1 over, or negative 3 times 1 over x squared.
whoa, what's the derivative of negative 3x? What's the slope?
Oh, sorry.
Just negative 3. Just negative. Careful, careful. You're overcomplicating that. Okay, so good. Let's continue. Now we're going to do the derivative of the next term. So we did the product rule here. Good. Go ahead, do the next one. Let's hear this time from Danny. Danny. I see a power, therefore I should use what rule?
The
Danny.
power rule?
Anybody else? Yeah, so tell me what to write. Plus
12y squared times
followed by
y
the chain rule. Very good. Equals. Now we're going to take the derivative of a constant. What's the derivative of 10?
0.
Zero. Okay, what's your friend?
Rewrite.
Rewrite it. We have to make this rewritten. So let's rewrite it. I have 4x minus, the number is going to be 6x. Go ahead and look down, rewrite it yourself. You'll be much faster if you just look down. Okay, so I got a negative 6xy prime minus 3y squared equals 0. Cool. Okay, let's think about what the question wants. It wants me to find y prime. So let's underline every term where we see y prime. There's a y prime here in this term. There's a y prime here in this term. There's no y prime in the circled expression. Is everybody okay? So if I want to get y prime by itself, my next step, step 2, is keep all y prime terms, the ones we underlined, so underline that. Keep all the y prime terms on the left. Move the other terms to the right side of the equal sign, to the opposite side of the equal sign. So I'm going to move what I'm circling in blue. I need to move my 4x, and I need to move the 3y squared, but it's a negative 3y squared. So how should I move the 4x? Adding, subtracting, multiplying, or dividing? What will I do?
Divide and add.
Not divide, because you don't want to divide up.
Subtract.
Subtract 4x, right? Subtract 4x on both sides. What else do I have to do to both sides to get rid of the other guy?
Add 3y squared.
Add 3y squared. Add 3y squared. So my new expression is negative 6xy prime plus 12y squared y prime equals, and now I have negative 4x plus 3y squared on the right. Everybody okay with that step? I kept my y prime terms on the left. I moved all the other terms to the right. Now you'll see why we did that. So step 3, we're going to factor out the y prime using GCF. So if we want to get y prime by itself, the way to do that is to factor it out. So what should I take out from both terms? Just
negative 6.
It's the y prime. So some of you are saying negative 6. I see the temptation. But don't we want to get y prime by itself? Eventually, we only want y prime on its side of the equal sign. We're only going to factor out y prime. Only. Make a note. Only. So what are we left with?
Negative 6xy plus 12y squared.
Very good. Everything else, we took out the y prime, and the right side stays the same. Now in the last step, think carefully. What should I do to both sides to get y prime all by itself and answer the question?
Divide by that 6xy.
Okay, that's our last step. Step 4. Divide to isolate y prime. So I'm going to divide both sides by negative 6xy plus 12y squared. Divide by negative 6xy plus 12y squared. And so my final answer is y prime equals, okay guys, slow down. I hate having a negative in the front. So can I just swap the positions?
Yes.
3y squared minus 4x. If you understood, do the bottom. What are we writing on the bottom? No negative in front.
12y squared minus 6xy.
Yes. Ta-da! And we answered the bloody question. We did it. We got y prime. We got the derivative. That, ladies and gentlemen, is implicit differentiation.
Yay!
So let's recap. What did we do? We took the derivative of both sides because it asked us for the derivative. Y prime, that's the derivative. But then we got a big complicated expression. So we moved all the y prime terms on the left. We underlined them and kept them on the left. And anything that didn't have y prime, we moved those to the right. So here they are moved over using addition and subtraction. Let me add that to my notes, using addition and subtraction. Next, I factored out the y prime. Since it was available in every term on the left, I factored it out. And so in my last step, I used division to isolate y prime. Cool. Let's try an actual AP problem. Ready? Number 2. This was on the 2015 AP Calculus exam. So it says find dy dx. What does that mean?
The derivative.
Derivative, y prime. For this equation. So step 1, what should we do?
Take the derivative.
Of both sides. Go ahead. Rafa, can you give me the derivative of y cubed, please? Careful, it's with respect to x. And guys, go ahead and do it yourself. There's more to argue there. Okay, Bridget, take the derivative of y cubed.
3y times y
Ah, that's fun. Careful, power rule. 3y
times
squared.
Third.
Oh,
Bring the power down by 1. Keep going, times
y prime.
Very good. Guys, what should I do for the next piece?
Product rule.
Product rule.
Make sure you circle the negative with the x. Y. Go ahead. What are we writing first?
Negative x times y prime.
The derivative of the right. Plus, now I hold the right.
Y times negative 1.
Very good. The derivative of negative x is negative 1. Equals, what's the
0.
derivative?
2 or 2, 0.
Rewrite.
Rewrite.
Right.
Go ahead and rewrite it carefully. So the only thing that changed was a minus y here. Equals 0. Okay, next step, what will we do?
Isolate.
Move the y prime terms.
Yeah, you can't factor out y prime yet because it's not in every
Move the
term.
terms.
We got to separate them. So what am I going to move?
Oh, why?
Y.
Y to both sides. Look down. You can do this. Looking down, you'll go faster. Equals y. What should I do now on the left side?
GCN.
Factor out only the y prime. So what are we writing? Y prime parentheses, what's left over?
Y squared minus x
3y squared minus x
equals y.
equals y. Final step, what should we do?
Divide.
Both sides by 3y squared minus x. We want to get y prime by itself. So final answer, y prime equals y over
Y squared. 3y squared.
minus
Minus
x.
6.
Okay. So was that pretty easy?
I want to say yes, but I'm scared.
Yeah.
Yes.
Sure.
The product rule trips
Sure.
me up.
Okay, now check this out. This was the AP Calculus question 2015. It said, consider the curve given by this equation. Guys, we just did that. And then they said, it can be shown that the derivative is this. Isn't that what we got?
Mm-hmm.
Now, here was the question. It said, write an equation. Copy this down. Write equation of the tangent line at the point -1, 1. Write that down. We're going to do the AP question. Write the equation of the tangent line at negative 1, 1. First thing, what's the first flag that goes off in your head? Equation of the tangent line. What do we need?
The derivative one?
What does it mean to write the equation of the tangent line?
Is it the M I'm thinking?
Yeah, I'll be using this formula. That's the equation of a line.
Yeah.
So what two things do we need for the equation of any line?
The point and the
And the
slope.
point.
Step 1, we're going to find the point. Hey, they gave me the point. No work. Write down negative 1, 1. They gave me already the x and the y value. What do I need next?
Slope.
Step 2.
Slope.
Slope. So I'm going to write not f prime, because there is no f here, but we're going to write y prime. Okay, y prime. But I don't want any slope. I want the slope at that point. So watch my writing. We're going to find y prime at negative 1, 1. That's how we'll show it. Y prime at negative 1, 1. Hey, didn't we just find y prime up here? And it's given right here.
Yeah.
So we need to plug in negative 1 for our x's and positive 1 for our y's. So on top I have y. So I'm writing 1
over.
3
Continue.
squared.
Minus.
Negative 1.
Minus, now I want the x. So
Plus
negative
1.
1. So plus 1 minus negative 1. Let's finish. 1 over, is that 3 plus 1, which is
1 over 4.
4. Okay, we found the slope. We found the point. Now what's my final step?
The equation.
Write the equation. Let's use this formula. So we're writing final answer, y minus 1 equals, what's the slope?
1, 4.
Parentheses x minus
X plus 1.
x minus negative 1 or x plus 1. Ta-da! You answered a real AP relief question from 2015. You can do it. You guys can do this.
We can pass the test in 2015.
You
guys.
are going to crush this test. Okay. We're finishing with the final part. So I can do this part in 10 minutes. So if you
I
can
have a
stay-
question. One quick question.
Yeah.
How would you find the point if it wasn't given to you?
Oh, they would have to have given you if they gave you the x, then you would have used factoring, I guess, to find the y. That would have been challenging. But if they gave you y, then you would have just solved for x. That would have been easy. Using the original function for the point. Using the derivative for the slope.
But
That's why
either
they-
way, you have to solve for one of the variables.
Yeah, but when it comes to implicit, they'll always give you the x and the y because it's mixed up. Notice that when we were doing explicit, we were finding the y value ourselves because it was y equals. It was super easy. Okay, part 3, differentiability and continuity. Okay, 10 minutes on the clock. You can time me. Ready? Draw this graph with me. Okay, so let's label points A and B. If I have an open circle on A, and then it continues, let's take it over to B, open circle there, then we're gonna continue straight up, and we're gonna go like that, and that's at C. Okay, so we have A, B, and C. So differentiability is just a fancy way of saying the derivative exists. That's all it means. Differentiability means the derivative exists. So observe, at x equals a, the derivative can't exist because the left-hand derivative is not equal to the right-hand derivative. So the derivative, this is not differentiable. At x equals a, because we have a jump. Okay, let's look at b. At b, maybe the left-hand derivative and the right-hand derivative are equal, but the slope doesn't exist at b because we don't even have a point. The graph itself doesn't even exist at b. Actually, even if it did exist, let's put a point up here. It's still not differentiable because there is a hole. So it's not differentiable at x equals b because of the hole.
Wait, the limit exists there though, right? But
The limit exists, but the derivative doesn't exist. It's just, we can't take the derivative at a single point. There is no derivative here. Because derivative implies change. There's no before, there's no after.
Wait, so when does the derivative exist?
I'm going to tell you, we're going to find a pattern. At x equals c, what do we have happening at x equals c?
Asymptote.
Infinite discontinuity.
Infinite discontinuity.
Yeah, another discontinuity. We have a vertical asymptote. So what you're learning is this. If there's a discontinuity, it's not differentiable. So all of these are discontinuities. Write this down. So we can't be differentiable at discontinuities. What did we learn? If f of x is differentiable, the first step, it has to be continuous. Step one, it must be continuous. And what we just saw are 3 cases where it's not continuous, and so therefore it's not differentiable. At holes, vertical asymptotes, and jumps, the slope does not exist. Okay, there's 2 more cases though. So leave space for part 2. Here's another example. Draw the y equals absolute value of x graph. Okay, at x equals 0, the slope doesn't exist. Why?
Because there's nothing going on.
It's a sharp corner.
The sharp corner. So the left-hand derivative is negative. The right-hand derivative is positive. So even though it is continuous, it's not differentiable. So write down at sharp corners. This is when it is continuous, but it's still not differentiable at x equals 0 because we have write down sharp corner. We learned this last time, if you recall. Also, one more case where the derivative doesn't exist. Draw this graph. So it flattens here, and then it goes straight up here. Please draw this graph. Okay, I'm going to point out 2 very important things. At x equals 0, does the derivative exist?
No.
No. Think, what's the slope here? What's the slope of the tangent line?
0, right?
Here it's positive. Here the slope is 0. 0 is a number. The slope exists. Here it's differentiable. We have a horizontal tangent line. We know that the derivative is 0. That exists. But look
So
at this
would it
one.
only not exist when it's undefined?
Yes, guys, what's the point? What's the slope of a line like this, straight up and down?
Nothing.
Does not exist because the rise is infinity and the run is 0. Right? Isn't the slope of that does not exist? If you didn't know, write it down. Here, f prime of x does not exist. So what you're learning is at vertical tangent lines. If the tangent line is vertical, the slope doesn't exist. But if the tangent line is horizontal, the slope does exist. So don't forget. Here it's 0, here it does not exist. Again, 0, the slope is 0, the slope doesn't exist. All right, so sharp corners and vertical tangent lines. So there's 5 cases really where, oh wait, hold on, my notes didn't make any sense. Sorry, you guys, sorry, you guys. Okay, for step 2, because it says f of x is differentiable. It must be continuous, meaning that the left-hand limit equals the right-hand limit equals the value. Remember, that's what continuity is. Left-hand limit is right-hand limit is value. And on the right, and then step 2 is the left-hand derivative equals the right-hand derivative. Sorry if I threw you off. So let's review. What are the 5 cases where I'm not differentiable?
Sharp corners.
Sharp corner, what else?
Better jump.
A jump, what else?
Asymptote.
A vertical asymptote, what else?
A hole.
A hole, so all the discontinuities. And a sharp corner and
Vertical tangent line.
tangent lines. Very good. So that's where you are not differentiable. So it's not differentiable at jumps, holes, vertical asymptotes, and add to that list sharp corners and vertical tangent lines. Those are the 5. Study and know those. The top kids are already like internalized it. I've already internalized it. So let's try an example. We'll go to number 1.
Miss,
You don't have to copy this down, yeah?
I have to go because my club started already.
Okay, you can go. I'm going to finish in 2 minutes for everybody else.
Bye, miss.
Bye. So it says, where is the graph not differentiable? So let's look at the points. I'm looking for sharp corners, vertical tangent lines, and any discontinuities. Where's the first place where f of x
There's
is
a
not
very sharp corner at 1.
at -1, yeah, right there. So at a equals -1, I'm not differentiable. What's the next one? Reading from left to right, where I'm not
4. There's a jump
because
discontinuity.
8.
also at 8, because we have a sharp.
11.
And 11, very good. At 11, what do we have?
Vertical tangent line.
Vertical tangent line. Very good. That was fast. So please understand you're looking for all those. 11 is the tricky one people forget. Okay, let's go to part B. Now, where is it continuous but not differentiable? So call this scenario 1 or condition 1, and this is condition 2. So I need it to be continuous but not differentiable. So can we restrict ourselves to the points we already talked about?
Yes.
Yeah.
Okay, which one is continuous but not differentiable? What about -1? Is it continuous?
Yes.
And it's not differentiable, so -1. It's continuous, we don't pick up our pen. Ashley, what's happening at 4? Is it continuous?
No, because there's a jump. So the next one would be.
So the answer, so we're not going to include that. Guys, write 4, put an X through it. It doesn't satisfy condition 1. It says it has to be continuous. Okay, guys, what about 8?
Yeah.
Yes.
It's continuous.
Part of our list. It's continuous and the derivative doesn't exist. What about 11?
Yes.
Yes.
Continuous and the derivative doesn't exist. Nice. Okay, let's look at the last one. It says, where are you discontinuous but the limit exists? What's our only point that satisfies the discontinuous?
4.
4, so I restrict there. Next question, does the limit exist there?
Oh, because the left-hand limit does not equal the right-hand limit.
Left-hand limit and right-hand limit are not the same. So we say no solution. There is no place here that's discontinuous, but the limit exists. By the way, what are the only types of points that are discontinuous, but the limit exists?
Holes.
There's no holes. So therefore, we're done. Okay, I promised you we would finish, so we're done. Put your pencils down. Let's see who can just answer these questions. Let's look at this example. Okay, put your pencils down. So quick check. Where is this not differentiable? Basic question. Let's start with Von May. Von May, where is this not differentiable?
-3.
At -3 because there's a
Jump.
jump. Where else is it not differentiable?
0. Wait, no. Scratch that. Negative 1. I think.
Very good, at -1 because there's a
Vertical asymptote.
vertical tangent
Vertical line. Sorry. It's vertical tangent line. I'm so sorry.
Good job. Next, let's talk to Isaiah. Actually, let's talk to Brandon. We haven't talked to Brandon yet. Where is it differentiable, but not, what's the second question? Continuous, but not differentiable. Where is it continuous, but not differentiable? Brandon? Never mind. Isaiah? Continuous, but not differentiable.
-1.
And -1, that's the only place where it's continuous and not differentiable. Here, it's not even continuous. Okay, last question. What's write this down, the interval of continuity, rather differentiability. So this is the last idea. The interval of differentiability says, from left to right, give me all the x values where you're differentiable. So isn't this differentiable everywhere that I've highlighted so far? Yeah, everywhere so far?
Yeah.
Until -3. So the interval of differentiability is -∞ to -3. Okay, what's my next interval of differentiability?
-3 to -1.
Very good. Between -3 up to -1, it's differentiable there. But at -1, it's not differentiable. We have a vertical tangent. So then we continue. I'm differentiable from -1 to infinity.
Nice.
The trick here is figure out where you're not differentiable, which was these 2 points, and then simply exclude them. So I excluded -3, and then I excluded -1. All right, we're done. Good job, everybody.
Bye.
I'm
Your
so
office
proud.
hours are at 3:50, right?
That's right.
Okay, sounds good.
We'll do the homework. We'll do the beginning of the homework in office hours. Bye, y'all.
Thank you, Miss.
I
Welcome. Bye. If you have any questions, say if you have any questions I can answer.